All right, let's get started by drawing a Lewis structure for possibly the most well-known compound ever, covalent compound ever, water, or H2O. My first step is I need to find out how many different atoms are in my structure. So I'm going to count each different element and look at the subscripts, also called the little numbers. We call those subscripts. So I have one oxygen atom, and I have two hydrogen atoms because this hydrogen has a 2 for its little number or subscript. So I've got 3 total atoms. Next, I need to total up how many valence electrons I have between all of my atoms. So let's go look at the periodic table. I can see in my periodic table that my hydrogens are in column 1, so they each have 1 valence electron. And my oxygen is in column 16, aka group 6A, so it has 6 valence electrons. So I'm going to keep a total over here. I have 1 from one hydrogen plus 1 from another hydrogen plus 6 from oxygen. So I have a total of valence electrons that I'm going to need to assign during this model. So remember, keep track of where these valence electrons are going. So I've found the valence electrons, I've totaled them up. So I've done steps 1 and steps 2. Now I need to figure out where my central atom is. Now, usually this is the least electronegative atom, which means it's more willing to share electrons. However, in this case, hydrogen is more electronegative than oxygen, but it would be really difficult to put hydrogen in the center because we can't form multiple bonds to hydrogen. So in this case, we know that it makes the most sense to put oxygen in the middle. And the other kind of rule of thumb is if you have one of one type of atom and multiple of another, put the one where there's only one of them in the center. So I'm going to go ahead and draw my oxygen in the center and my hydrogens off to the side. All right, so I've done that step. Now I need to place lines between bonded atoms and subtract 2 electrons from my valence electron total over here for each bond. So there's a bond between an oxygen and a hydrogen, and there's a bond between an oxygen and a hydrogen. Keep in mind, each bond represents a shared pair of electrons. So every time I draw a line, I need to make sure that I subtract 2 electrons from my total. So minus 2 for both of those bonds. I've got 4 remaining, which means I still have 4 that I need to assign to my structure here. Gonna check off that step. Now I'm going to begin placing dots around the outer atoms as lone pairs until all electrons have been used. Now, again, this is one place where this rule isn't entirely true. I can't fit any more electrons on my hydrogens. So in this case, I'm going to have to put them on my oxygen. So we're going to put a lone pair on oxygen and a lone pair on oxygen. I'm going to straighten out my lone pair a little bit down here. A lone pair on oxygen. So now I have 1, 2, 3, 4 electrons used up. So I'm going to move my total over here so I have more space. I've spent all my valence electrons. Done. So now I need to turn lone pairs into double or triple bonds until all atoms have a satisfied octet rule. Well, let's check the octet rule. Hydrogen is getting 2 valence electrons from this bond right here, and it only needs 2 to have a full shell or a full valence energy level, so it is satisfied. This hydrogen is satisfied too, and oxygen has 2, 4, 6, 8 total valence electrons, so its octet is satisfied as well. So we have created the correct Lewis structure for our oxygen, for our water molecule.